Good day, everyone. Welcome to Flip Lectures in Chemistry. Today, we will be talking about the different factors affecting solubility. When we talk about some solutes, like table sugar, for example, this solute readily dissolves in water. However, there is a limit to how much sugar can dissolve in a given amount of water at a given temperature. At some point, no sugar dissolves even when more and more of its crystals are added to water. The solubility, therefore, of one substance in another is affected by the following factors, such as, for example, the nature of the solute and solvent, we have the temperature, and even the pressure. Today, we will be talking about those different factors. When we talk about solubility, once again, as a review, refers to whether or not a solute will dissolve in a solvent and the extent in which it will dissolve. The amount of solute that will also dissolve or that will dissolve in a specific solvent at a given condition is also referred to as solubility. Okay? Next, here are the different factors once again that affect the rate of solubility. When we talk about the different factors, we have temperature. We have to remember when we talk about temperature, as there is an increase in temperature, the rate of dissolving also increases. We also have factors such as agitation, shaking, and stirring, which will be discussed later on. And we also have the surface area of solids. When we talk about the nature of solute and solvent, we have to remember covalent and ionic bonding. Materials differ in solubility. So, the solubility of different substances are actually based on their polarities or on the polarities of their solute and solvent. For example, a polar solvent is a liquid made up of polar molecules. So both solute and solvent that are polar are said to have a polar-polar interaction. What about for the case of a nonpolar solvent? A nonpolar solvent is a liquid made up of nonpolar molecules. For example, when we have both solute and solvent having nonpolar uh, characteristics, we come up with a nonpolar interaction. Okay, so the nature of solute and solvent once again. When two substances are similar, they can dissolve in each other. So polar solutes dissolve polar solvents. Example is, for example, sugar and water. We also have, let's have, for example, another one. Nonpolar solute tends to dissolve in nonpolar solvents. So, for example, we have oil and kerosene. Okay? So, like dissolves like. When two liquids dissolve in each other because their molecules are alike in polarity. I missed to show to you a table, but I will be showing the table later on. Okay? So, like dissolves like. Again, when we still talk about solute or the nature of solute and solvent, ionic compounds are made up of charged ions similar to polar compounds. So basically, when we talk about ionic compounds that are placed in polar solvents, ionic compounds are easily dissolved. One classic example, table salt, which is dissolved in water. Ionic compounds are also more soluble in a polar solvent than in a non-polar solvent. That is why table salt is not easily dissolved in alcohol, which is an example of a non-polar solvent. Okay? So sa tubig, dasig siya since it is a polar solvent, but ang salt hindi sa dali-dali matunaw sa alcohol. It is because alcohol is a non-polar solvent. So again, for example, when we talk about the table of solute, we have for the case, for example, of polar solvent, a polar solvent or a polar solute is soluble in a polar solvent, but insoluble in a non-polar solvent. Again, one classic example of polar to soluble in polar solvent is salt water and, salt and water. polar to non-polar, which is insoluble. A very good example of this is our table salt and our alcohol. What about for the case of non-polar and polar solvent? For example, non-polar, we have oil and water. For example, a non-polar solute, which is oil, will not be dissolved in water, so it is insoluble. But for the case of non-polar solvent, so a non-polar oil, for example, going to kerosene, oil is dissolved in kerosene. Okay, so that's non-polar to polar and non-polar to polar. What about for the case of ionic types of solution? For ionic types of solution, for example, table salt, it is soluble in a polar solvent. So table salt to water. What about table salt going to alcohol? Once again, table salt going to alcohol, it is insoluble. So it is not easily dissolved in alcohol. So there are different factors aside from the nature of solvent and solvent. We also have temperature. When we talk about temperature, the solutions of gases and liquids are affected by temperature. As there is an increase in temperature, the solubility of gas in a liquid tends to tends to what? Tends to it tends to decrease. Okay, ang iyang solubility ga decrease sa liquid. Why? It is because that as the temperature increases, the kinetic energy of the solute gas increases and the gas can escape. So gapalagyo na ang liquid or ang gas from the container. So the solubility of solids in liquids, on the other hand, is a total opposite. Why? If we talk about the solubility of gas, as there is an increase in temperature, once temperature is increasing, there is also an increase in the solubility of solid particles. So total opposite. So the solubility of solid particles increases as temperature is increasing. But there are a few exemptions to it. Okay? Next, we also have what we call pressure. Pressure is another factor that can increase the solubility of a particular material. We have to remember that when the pressure is increased over the solvent, the solubility of the gas is also increased. This is applicable, for example, in the soft drinks placed in bottles or containers. Why? Because pressure increases, or as pressure increases, it also increases, or the gas molecule strikes the surface to enter the solution is also increased. So according to Henry's law, which will be discussed further in the next edition, solubility of the gas is directly proportional to the partial pressure of the gas above the liquid. This is applicable for the case of the dissolved gases with increased pressure in liquid. So we're in liquid. So as pressure of the gas above a liquid is increased, the solubility of the gas also increases. So again, this is applicable sa mga soda. Okay? Soda or okay, again, applicable sa mga sodas. Okay? Soda. Okay? And even in soft drinks. What about for pressure? Still in pressure again. Pressure or pressure as a factor in increasing solubility is a potential problem also for scuba divers, which is uh, actually known as narcosis or the bends. Nitrogen dissolves in blood at high pressure under surface water. So when scuba divers are going down deeper the ocean or the bodies of water, their body tends to increase in terms of the production, or tends to increase the production of nitrogen. So even though there is a higher production of nitrogen in the body, but the body under higher pressure or surrounded by higher pressure can dissolve nitrogen in a fast way. But if the divers ascend too fast, nitrogen bubbles out of the blood will also come out directly, much like carbon dioxide in poop or in pop. So what happens is that as the amount of nitrogen tends to increase and the body of a person tends to move from an area of higher pressure to a lower pressure, the dissolution or the body's ability to dissolve nitrogen will become lower. And that can be painful sometimes and also fatal. That is why uh, scuba divers are advised not to ascend too fast from a lower part of the body of water to a higher part. So, kinangani nahihinay lang. So, tandaan nyo, gid, nga hindi ka mo magdali-dali sa kayo will be experiencing what scuba divers are also experiencing. We call that bend. Another factor is what we call surface area. Dissolving solutes happen in the surface area of the solvent. The dissolution or the dissolving of solute speeds up the process by increasing the surface area. Okay? So the greater the surface area per unit mass, the quicker the solute will actually dissolve. So aside from surface area, we also have stirring. So dissolving happens at the surface of the solvent. So the contact between the solvent and the solute is increased through stirring the solution. Okay, so it will be increasing the solubility of a particular solute. So again, we go back to temperature. Raising the temperature increases the rate at which the solute is dissolved. Solvent particles move faster as they come in contact with more solutes. So this is increased by temperature. So at which gas will you get a fizzier glass of pop or cold of pop, cold or warm? Okay? So the correct answer is warm. Why? Because as the solubility of carbon dioxide, or when we talk about increase in temperature, the solubility of carbon dioxide will be decreasing. Okay? So, muna, kinanglan, kung gusto nyo nga, no, inom ka mo soft drinks nga init. Okay? Or warm. Kaya nga, ang solubility sa carbon dioxide, ganubo na sa dayon. Okay? So heat pollutions in water. Many industries tend to return warm water to lake or rivers. What effect would this have? Dissolved H2O. So because there is more there are more dissolved O2 or oxygen in water compared, for example, I mean, if we have, for example, dissolved oxygen in water, marine life will actually suffer. Why? Objects under the sea also need oxygen for their survival. So as a form of review, there are different factors that affect the rate of dissolution or the dissolving of solute. We have the first one, temperature. We also have the particle size. We also have agitation through stirring. So also, there are some important keynotes to remember, like dissolves like. Forces between solid and solvent particles are very important, and the solubility of gas in liquid tends to be different if there are changes in temperature and pressure. So that ends our discussion for today. This is Flip Lectures. Good morning.